Let's suppose we have two sets. Set A contains the elements A, B, and C. We have another set B which contains the elements 1, 2, 3, 4, 5, and 6. Now when we take the Cartesian product of our two sets A and B, it's going to have 18 elements. So we have already talked about it. So the number of elements in the Cartesian product of A and B is simply equals to the number of elements in set A multiplied by the number of elements in set B. So in set A we have 3 elements, and in set B we have 6 elements. So 3 times 6 gives us 18. So that will be the number of ordered pairs present in the Cartesian product of A and B. So when we find out the Cartesian product, so we can list them out. So we'll pick up the first element from set A and form an ordered pair with each of the elements of set B. So we'll have A all the way up to 6. Then we pick up the second element and form the Cartesian pair with each of the elements of set B. So we'll have up to B6. And similarly for C1, for the third element C, we'll have all the elements listed in this set. Now from this set, we can obtain a subset of A and B. So let us consider a subset of the Cartesian product of A and B. This is going to be done by introducing a relation R. We're going to introduce a relation R between the first element and the second element of each ordered pair X and Y. So we are considering a relation R, which is a set of the ordered pairs X, Y, such that our X, which belongs to set A, is a consonant of and Y. Let's write down the relation in such a way that X is a consonant when Y is an odd number. And we have X belonging to set A and Y belonging to set B. So what we can do, we can find out the relation, we can find out all the ordered pair which satisfy this relationship between X and Y. So if we are to pick up the consonant B, so B is a consonant, then the Y must be picked up from B and it must be an odd number. So we have 1. The next ordered pair will be B3 and the next one will be B5. Then we go for the second consonant in our set A, which is C, and we have to pick up odd numbers from B. So that will be C1, C3 and C5. So what we have done is we have formed a subset. We have formed a set R, which is a subset of our Cartesian product of A and B, and also there is a relationship between the first element and the second element of the ordered pairs in A and B. So let us write down the definition. So our definition states that we have a relation R from a non-empty set A to a non-empty set B. It is a subset of the Cartesian product of A and B. We can visually represent the above relation using a Venn diagram. So for the two sets A and B, given by the elements A, B and C for set A and 1, 2, 3, 4, 5, 6 for set B, we have the Cartesian product of A and B given by the 18 ordered pairs. Now we can represent this using a Venn diagram. So what we'll do, we'll consider a Venn diagram for the set A. So we're going to list out all the elements. So we'll have A, B and C. Then we consider another Venn diagram. And we're going to list out all the elements present in set B. So that will be 1, 2, 3, 4, 5 and 6. Now the visual representation is when we consider the element, and let's also write down the relation formed between A and B. So we have a relation R going from A to B. So that relation R is defined as, so we have the relation R, which is a subset of the Cartesian product of A and B, and the relation is so defined as that whenever we pick up a consonant in set A, that gives us an odd number in set B. So we start with the consonant in set A, which is B, then that should give us a consonant that gives us an odd number. So we'll draw an arrow going from B towards 1 in set B. Then we draw another arrow going from B towards the second odd number, which is 3. And we have another arrow going from the consonant B towards the odd number 5. Then we have another consonant in our set A, which is C. So we'll draw an arrow going from C towards the odd number 1 with an arrow pointing towards it. Then another arrow pointing from C towards the odd number 3, and another one, it's pointing towards the odd number 5. So this is a visual representation of a relation going from A to B using arrow diagrams. Now here we can define certain things. The first thing that we can define is the domain of the relation R. So let us define what was meant by a domain. So a domain will be defined as the set of all first elements of the ordered pairs in a relation R going from set A to set B. So we have here the set of all first elements, so only the elements that were involved in the relation from set A, so that is the consonants B and C. So when we have a set B and C and we consider only the elements that were involved in forming the relation or the forming of the ordered pair, will be termed as the domain of the relation. Then we have another set of values which participates in this relation, which is the second element. The second elements are 1, 3 and 5. Those elements are called the range of the relations. So let us define a range. So the set of all second elements of the ordered pairs in the relation R going from set A to set B will be called the range of the relation R. So here we have the second elements 1, 3 and 5. So this will be the range of the given relation. So let's not confuse this range with the relation R. So let me rewrite it as range is equals to the elements, the second elements, which will be 1, 3 and 5. Now here we are considering only the elements which are participating in the formation of the ordered pairs from set B. If we are to consider all the elements, the whole elements from set B, then those set of elements will represent the codomain of the relation. So the entire set B is referred to as the codomain of the relation set, of the relation. So the codomain will be the set containing the elements 1, 2, 3, 4, 5 and 6, or simply the set B. So clearly we can see there is a relationship between the range and the codomain. So here we can say that the range of our relation is a subset of the codomain. So there is one more element, one more terminology that I'd like to add here. These elements which are participating in B, so that means either elements 1, 3 and 5 are respectively the images of B and C, meaning, so we have 1, the 1 is the image of B. The second element 3 is an image of B. The third element 5 is an image of B. Similarly, 1 is also the image of C, 3 is the image of C, and 5 is the image of C. So a relation may be represented algebraically either by the roster method or by the set builder method. So let us do an example, and we're going to implement both the method to represent a given relation algebraically. So here we are given a set having 6 elements, 1, 2, 3, 4, 5 and 6. So we have to define a relation R from A to A, which is given by X, R, Y, where the relation between Y and X is Y is equals to X plus 1. So here, as a relation R is going from A to A, so that means the ordered pair that is going to be formed, the ordered pair X and Y, the elements X and Y are both going to belong to our set A. So let us pick the first element 1. So let's suppose X is equals to 1. Then we can use the relation that Y is equals to X plus 1. So that will give us the value of Y. So the value of Y will be equals to 2. When we pick up the second element, X is equals to 2, that will give us the value, corresponding value of Y, which will be equals to 2 plus 1 equals to 3. Let's complete this. So for X equals to 3, we'll have Y is equals to 4. For X equals to 4, we'll have Y is equals to 5. For X equals to 5, we'll have Y equals to 6. And for X equals to 6, we'll have Y is equals to 7. We'll have to be a tad careful here, because whenever we're considering X equals to 6, that's giving us the Y value as 7. But we know that Y, it belongs to set A, but the number 7 does not belong to set A. So we are going to reject the value of X equals to 6. So now we can form the ordered pair for the relation R. So let's list them one by one. So we have when X equals to 1, that gives us Y equals to 2. For X equals to 2 gives us Y equals to 3. For X equals to 3 gives us Y equals to 4. For X equals to 4 gives us Y equals to 5. And finally for Y equals to 5 we get X equals to 6. So this is going to be our roster form. And using this roster form we can write using the set builder form. So our relation R contains all the elements, all the ordered pairs X and Y, such that the relationship between Y and X is given by Y is equals to X plus 1, and our element X belongs to set A, so does the element Y, which also belongs to set A. So this is going to be the set builder form. Now we can find out the range, the codomain and the domain of the relation. So let's start with the domain. So the domain, this domain is the set of all the first elements in our ordered pair. So the first elements will be 1, 2, 3, 4 and 5. So these are all the first elements in our relation. Then we have the range. So the range will be all the second elements in the ordered pair. So that will be 2, 3, 4, 5 and 6. And finally we can have the codomain. So the codomain will be the entire set B, which will be the value of Y. So Y will be 1, 2, 3, 4, 5 and 6. So let us try, now that we have the domain, range and codomain, so also let's try to represent it pictorially. So we will have, So we draw a Venn diagram. Let's draw it bigger. So we have a Venn diagram for the set A, and we list all the elements contained in that set. So we have 1, 2, 3, 4, 5 and 6. Then we have the same set A, which is represented in another Venn diagram, and we list all the elements present in set A, 1, 2, 3, 4, 5 and 6. Then we begin by selecting the first element of set A, which is 1. Then the corresponding element is 2. So when we select 2, we get 3. When we select 3, we get 4. When we select 4, we get 5. And when we get 5, when you have 5, we get 6. So this is a relation going from A to A. Let us do another problem. So in this question, we are provided with a pictorial representation of a relation going from A to B. So before beginning to solve the question, let me specify here that the first set is A and the second set is B. So that also tells us the order of the relation, that we are going from A to B. So let us begin by listing the ordered pairs. So that means we are going to write the relation in the roster form. So for 9, so when you pick up the element 9, the corresponding element in B is going to be 3. When we pick up 9, the corresponding element in B is -3. For the second element, 4, the corresponding element in set B is going to be 2. And we can form another ordered pair with 4, so which will be -2. That is the element picked up from set B. And for the third element in set A, so we have the first ordered pair formed with 5, +5, and another ordered pair formed with -5. So this is the ordered pair. So we have listed out all the ordered pairs, and this will be a roster form. Now clearly we can see that the elements in A is simply the square of the elements in B. So what we mean is that when you consider the first ordered pair, the element 9 is square of the element 3. Similarly, when we consider 9, it's also the square of element -3. We can check out for all the other elements in the remaining ordered pairs. So let's see 25 and -5. So 25 is the square of -5. So now we can rewrite this relation in the set builder form. So that is the collection of all the ordered pairs x and y such that x is equals to y squared, where x belongs to a set A and y belongs to the set B. So this is going to be the set builder form. So now that we have both the roster form and the set builder form, we can specify the domain. So the domain is going to contain all the elements. It's the set containing all the elements, all the first elements from set A, picked up from set A. So that is going to be simply 9, 4 and 25. It's without even looking at the roster form, we can also quickly determine the domain of our relation by looking at this graphical representation. So we see that 9, 4 and 25 has participated in forming a relationship with the elements of set B. So all the elements that participates are going from set A, picked up from set A, are going to be the domain of the relation. Then we can find out the range. So range also will have the same criteria. All the elements that are participating while forming the relation will form the range. So for set B, we have 5, 3, 2, -2, -3 and -5. So these are the 6 elements which have participated in the sense that there's 5, 3, 2, -2, -3 and -5 are all images of the respective domains. the respective elements on the domain. Then we have the codomain. So codomain will be all the elements of set B. So I'm simply going to write it as codomain is equals to the set B.